Hey everyone, in this video we're going to go over how to find the constants a and b so that this function is continuous on the entire real line. And in my previous video I said do this on your own, and so let's go over it. I didn't want to leave you hanging. So here, looking at this function, this is possibly not continuous at x equals 2. That's where we have potentially a hole in the graph, but notice that it's not included at 2 there, so then we're okay. So we need to check continuity when x is 2, because that's where we have a possible jump in the graph, and we also need to check continuity at x equals 3, because that's where we have another possible jump in the graph, or a hole, right? So this is a quadratic, quadratics are continuous, that's a line, lines are continuous, so we have a risk of the function, when we piece those two together, not being continuous when x is 3. So let's go over our continuity checklist. So what are the 3 things that we need? The 3 things that we need to check are that for continuity at x equals a, that f of a exists, that the limit as x goes to a exists, and that the limit and the function value at a are the same. And so the thing to remember about the limit exists, this means the limit as x goes to a from the left has to equal the limit as x goes to a from the right. So that's what it means for the limit to exist. So here we're checking continuity at a equals 2. So we're going to check for a equals 2 and for a equals 3. So let's start with a equals 2. So here's our a equals 2, here's our function, so we're going to check the 3 conditions of continuity for a equal to 2. So the first thing is we want to check, does f of 2 exist? So let's see, where are we allowed to plug 2 in? This one says x less than 2, not equal to, so not there. And even if I try to plug it in, right, it wouldn't work. But I can't plug it in there because it does not have the equals. So what about this one? This says ax squared minus bx plus 3 if 2 less than or equal to. So this one has the equals, so that means I can't plug it in here. So that means that f of 2 is going to be a times 2 squared minus b times 2 plus 3. And so f of 2 equals 4a minus 2b plus 3. So does it exist? Yes. I'm looking for the constant a and the constant b so that the function is continuous. Once I have that, I'll be able to get a numerical value for f of 2. But yes, it does exist. 2, the limit has to exist as, no, I guess I should have picked a different variable here. Let's just say when x is 2 and when x is 3. We don't want to confuse that with this little a that we're looking for. So for the limit to exist, that's the second part of the continuity checklist. We want the limit to exist. So we want the left-sided limit and the right-sided limit to be the same. So in order to be continuous, we want the limit as x goes to 2 from the left of f of x to equal the limit as x goes to 2 from the right of our function. I think it was called g, but I already started using f, so let me just keep that. So as x goes to 2 from the left, so from the left of 2, which function are we following? If you are to the left of 2, you are what? Bigger than 2 or smaller than 2? Or smaller, right? If you're to the left of 2, you're smaller than 2. Think of the number line. You have 2 there, you're to the left of 2, that means you're on this side, so you're smaller. So less than, so I'm following this function. So this is going to be the limit as x goes to 2 of x squared minus 4 over x minus 2. And so we use our rules of limits to find this. Factor the numerator, because if you plug in 2, we're going to get 0 over 0, which means do some algebra. So factor, and so I can cancel these guys, and I'm just left with my limit as x goes to 2 of x plus 2. Plug in 2, I get 4. So the limit as x goes to 2 from the left is 4. What about the limit as x goes to 2 from the right? If you're to the right of 2, you are bigger than 2. So we're going to look at when x is greater than 2. So we're following that same function that we did for f of 2. So I already know then that this is going to then be the limit as x goes to 2 of ax squared minus bx plus 3, which is the same as f of 2. So this function will be right continuous. So this will be 4a minus 2b plus 3. Now remember, we said we want this to be the same. So now, since I want those to be the same, I'm going to set up an equation. I want this and that to be the same. So that means we'll have, so we want for the left-sided limit to be the same as the right-sided limit. And there's nothing I can do here, so except maybe subtract the 3. So minus 3 from both sides. I'm going to have 1 is equal to 4a minus 2b. And right now I can't really find a numerical value for a and b, so I'm going to keep this in mind and see what happens with my other continuity point when x is equal to 3. And because chances are I'm going to get another equation, and I can make a system of equations with a and b and solve for them. So let's check when continuity when x is 3. So continuity for x equals 3. So the same three things. Does f of 3 exist? So where are we allowed to plug 3 in? Top function, middle function, or bottom function? X is less than 3 there, does not have the equal, so don't plug it in there. X is greater than or equal to, so that's when we can be equal to 3, so I'm going to plug it in there. So it'll be 4 times 3 minus a plus b. So 4 times 3 minus, was it minus a plus b? Okay. And so f of 3 is equal to then 12 minus a plus b. The second thing is we want the limit to exist, so that means we want the limit as x goes to 3 from the left to be the same as the limit as x goes to 3 from the right. And from the left, let's look at what that limit is. As x goes to 3 from the left, so if you're to the left of 3, you're smaller than 3, so less than 3. So that will be the middle function. So we're following ax squared minus bx plus 3. So it's the limit as x goes to 3 of ax squared minus bx plus 3. Plug it in. So I get 9a minus 3b plus 3. So that's the limit from the left. The limit from the right will be the limit as x goes to 3. What function are we following from the right? If you are to the right of 3, you are bigger than 3, so greater than. So I'm following the bottom function, 4x minus a plus b, which is also our f of 3. So I want this to be, so we're following 4x minus a plus b, plug in 3, so we get 12 minus a plus b. We want these to be the same, so we set them equal to each other. So in order for the limit to exist, we want 9a minus 3b plus 3, right, the limit from the left, to be the same as 12 minus a plus b, the limit from the right. So let's do the same thing that we had done above, and so try to get it into just one equation with a's and b's on one side. So I'm going to, what am I going to do? What can we do? Subtract 3 from both sides. So I'm going to have 9a minus 3b equals 9 minus a plus b. And so bring the a's and the b's over to this side. So plus a, so then I'm going to have 10a minus b, so minus 4b equals 9. And so let's save this equation. So now notice I have this equation, and from x equals 2, I have this equation. They both have an a and a b, so I can make a system of equations with those two. So make a system to solve for a and b. So I'm going to have 10a minus 4b equals 9. And the other one, which was 4a minus 2b equals 1. Let me just see if I remember it correctly. 4a minus 2b equals 1. Yes. So I have two equations, two unknowns, and so now we get to solve this system. So you can use your algebra skills here to solve either by using the elimination method or by substitution. And so whichever method you prefer, you can solve this. And once you are done with that, I'm going to skip the algebra so that my video is not too long. You should get that a is, what did I get for a? 7/2, and b should be 13/2. So one of the things is, just to get you started, if you wanted to try the elimination method, is notice that those are already both multiples of 2. So I will multiply this whole bottom one by -2 to make that a positive 4b, so they eliminate, right? They cancel. That's the elimination method. And then this, once you do that algebraic work, you should get these. So that means that a equals 7/2 and b equals 13/2 will make this function continuous. So hopefully that helped. This one was harder because it has the 3 pieces, so you have to check continuity for one of the points and then for the other point, and that's how we get the system of two equations with two unknowns. Email me, let me know if you have any questions.